Okay, today I want to mention several topics that still missing in these videos that might be useful in some use cases and definitely interesting to understand how Git operates. And I'll mention several of them, and some of them is related to what I have already talked about. Some of them are new. Let's just start, and I will try to be quick this time. So the first thing that's missing is submodules. What is submodule? Well, you can have several repositories, and you want to make one repository depends on the contents of the other repository. Let's call it a dependency, right? And you don't want to store the dependency as a folder in your repository because it might be huge and you don't want to actually have it in your history, in the history of your repository. So you can reference repository, namely you provide the name of the repository, the path where it's located, and you specify the commit that you want to check out the dependency dependent repository. So to give you a quick example, let's create a dependency repository, check out cd into it, initialize the repository here, and let's add a single file here, file content, add this file to stage and commit everything, file, and here's our dependency repository. Now let's go back and create a root repository, our main repository, and I will reference the root repository as a super repository. Let's create a super repository and cd into it, and initialize git here as well. And for just let's create for demonstration, let's first create some file in it also, file txt, just to have a history, right? Add file, and now we have some history here. And now we want to actually attach a dependency repository that we created previously to this repository, and actually use. Why we want to do that? Well, there are some situations when you want to reuse the code from another repository as a library, etc. This is called a dependency. So we add that repository with git submodule add command. We specify whatever URL this repository has. It could be anything like https github or git add github, which is SSH URL. In our case, this is actually a relative URL in a local computer, and you specify a path to your dependency repository, and then you specify the folder where it should be located. Let's name our local folder for this repository the same way, and here we go. Now we have a file and a folder. File basically describes all the repository, all the dependency repository, all the submodules. Git calls dependency repository submodule. It describes a URL and a path. By default, this repository will be of version that is equal to head version of this repository of the submodule. Let's actually commit it -a. Give me a sec. Let me close this one. Okay, and now we need to commit this file. Let's commit it with add dep repository, and now we have a second commit here. And how we actually, if we now go to dependency, and here's our commit, here's our dependency submodule with, and now if we type git status here, you actually showing the status for submodule, not your super repository. And we have a single commit here. And what's now? Now you might want to actually change dependency repository, like so. You go to dependency repository, you for instance, you change file, adding a new line here, and you commit in everything, update file, and you go back to your super repository, and you want to actually fetch changes, and actually to change the version of this repository that our super repository is pointing to. To see the version that it's pointing to right now, you type git tree, and you need to because repository is stored only as a reference to whatever commit you want it to point on the remote repository. You can inspect this commit with git ls tree, and you specify the latest tree. And here we have a blob type to store a file. As you remember, we could have a tree type to actually describe another folder, nested folder, and we have this commit that actually specifies what version of submodule we want to have in our repository. And this is not an object stored in our repository, and you won't be able to find it. It's not a valid object because it's not in our repository. It's actually a reference to an object of submodule. So you go back to dep repository, and you can find these objects in it, and it actually commit that our repository, our submodule is pointing to. But now we have another commit in our dependency repository, and we want to check out. Well, for some time we let's imagine that we worked with this version of submodule, and now we want to migrate to the newer version. To do that, we go to dep folder, to our submodule, and we run fetch commands just to fetch all the changes from our origin. Let's take a look at git log. Here's our master, and if we take a look at git log origin master, it has an extra commit, and we want to check out our to check out head for it to point to an origin. You can do it by lots of ways. Let's just pull origin master git log, and now our master is pointing to actually the latest commit of submodule. We go back to super repository. You type status, and you see that it basically what we have just done. We changed the version of submodule and nothing else, and it will only change the version in the tree. It won't add extra files that we actually related to the last commit. The only thing it does is changing git ls tree head. It will change this line here. Not because it's not yet committed. We have an old version of submodule, but now if you actually commit everything, and commit is called migrate to latest dep version. And now if we take a look at ls3, we have a different commit now. So basically our tree is keeping track of submodules by pointing to a specific version, right? And by default, the only thing that's left in submodules topic to discuss is how to actually the situation when you have your repository cloned and your repository has some submodules like so, super repo clone, maybe someone else decided to clone it. You go to this cloned repository and you, even though you have a folder, it's empty, because cloning the repository itself and cloning the submodules are done in two separate steps, just for convenience. Maybe you don't want to clone the whole, maybe you have a lot of submodules, so you want to clone it as a separate process. And to clone it here, to initialize and clone it here, you have two commands that you need to run. Well, first of all, let's inspect git config. We have a remote here, a branch here, and no information about submodule. And when we run command git submodule init, it will populate our local config file. Remember, local config file only stored on your local machine. It's not moving with cloning. If someone clones your repository, the config file isn't moved, isn't cloned as well. So you have a submodule, a single submodule, and you have URL and active. And yeah, the active flag is true. And this is the first command, git submodule init, and then you need to update the commands update every time you change something in the submodule, and you want to repopulate a local version of submodule. You type git update, and it actually, if something is changed, it will clone the remote repository and it will check out a new version. And as you can see, we have version 6b7 of this repository. Let's quickly check, is it actually a correct version? Is it the latest version? Git log. Yes, and this is indeed the correct version of the remote repository. So this is basically it about submodules. You can have as many as you want. You might have 10, 20. It doesn't matter. Maybe you have a very big repository, a huge repository with a lot of dependencies, and submodules are basically a very good approach to decouple codes and make your code modulable. Meaning separated by modules, and each module can be very short and simple one, and you can couple and decouple them which is with each other with the help of submodules. Basically, this is the main idea of submodules. So for now, that's it, and in the next video we'll continue.